Hi students, today we are going to start with partial differential equations of MAT 201. Okay, partial differential equation, first module of MAT 201. So first of all, what's the definition of partial differential equation? What is a partial differential equation? Equation consisting of dependent variable, independent variables and partial derivatives is called a partial differential equation. So an equation consisting of dependent variable, independent variables and their partial derivatives is called a partial differential equation. So the example for partial differential equation is x into dou z by dou x plus y into dou z by dou y is equal to 3z. This is a partial differential equation. Also another equation, another example is here. Dou square z by dou x square plus 2 into dou square z by dou x dou y plus dou square z by dou y square equal to x square plus y square. These are examples of partial differential equation. Now I am going to, what is the order of a partial differential equation and degree of a partial differential equation. Also, before that, partial differential equation, abbreviation of partial differential equation is PDE. We can write a partial differential equation in short form, that is PDE. So, what is the order and degree of a partial differential equation? Next definition. What is the order of a partial differential equation? The order of a partial differential equation is the highest derivative, is the order of the highest derivative in that equation. So, look at this equation. In this equation, what's the highest derivative? Dou z by dou x, dou z by dou y. That is the first derivative. This is the highest derivative. So, the order of this equation is 1. Okay, order of the highest derivative is called the order of the partial differential equation. Also here, dou square z by dou x square plus 2 into dou square z by dou x dou y plus dou square by z by dou y square equal to x square plus y square. Here the highest derivative is dou square z by dou x square. This is also dou square z by dou x dou y. This is also dou square z by dou y square. So the order of this equation is 2. Okay. Now, what is the degree of a partial differential equation? Degree of a partial differential equation is the degree of the highest order derivative in that equation. So, what is the degree of these two equations? Look at this equation, first equation. The order of this equation is 1. So, the order degree of the highest order derivative. So, the degree of this derivative is 1. This degree of this derivative is 1. So, the degree of this partial differential equation is 1. So, order is 1 and degree is 1. Here, look at this. Here, dou square z by dou x square. Here, the order of this equation is 2 and the degree of the highest order, that is 1. All these equations are of degree 1. So, the order of this differential equation is 2 and degree is 1. These are the definitions of PDE, order and degree. Now look at this. If z is a function of x and y, then we have z equal to z of xy. So, z is the dependent variable and x and y are the independent variables. Then we get, here there are 5 partial derivatives. We get 5 partial derivatives, which are the 2 first order partial derivatives and 3 second order partial derivatives. Okay. What are the first order partial derivatives? Dou z by dou x and dou z by dou y are the 2 first order partial derivatives, and we denote this as dou z by dou x is equal to small p. This is the notation of dou z by dou x, and dou z by dou y is denoted by small q. Okay. Now we are moving to the second order derivatives. 3 second order partial derivatives arises, which are the dou square z by dou x square, then dou square z by dou x dou y, and then dou square z by dou y square. 3 second order partial derivatives. And what are the notations? Look at this. This is equal to, here we denote dou square z by dou x square as r, small r, and dou square z by dou x dou y is equal to small s, and dou square z by dou y square equal to small t. So, these are the 5 partial derivatives. Okay. having a function having two variables. If a function is having two variables, then we get 5 partial derivatives, 2 first order partial derivatives and 3 second order partial derivatives, and we denote notations are P, Q, R, S and T. Okay. Now the next topic. Now moving on to the next topic. The next topic is formation of a partial differential equation. Okay. Now the next topic is formation of a PDE. A PDE can be formed by two methods. Which are they? First one, by eliminating arbitrary constants. And second one, by eliminating arbitrary functions. Okay. First we have to study about formation of a PDE by eliminating arbitrary constants. Now the method of eliminating arbitrary constants. In this method, if the number of arbitrary constants is equal to the number of independent variables, then we get a PDE of order 1. So, if the number of arbitrary constants and the number of independent variables are same, then we get a PDE of first order. And if the number of arbitrary constants is greater than the number of independent variables, then we get a PDE of order more than 1, that is greater than 1. These are the most important things we have to remember while doing the problem. Okay, so this is the method of eliminating arbitrary constants. Now we are going to some problems. Okay. Now the first question, form a PDE by eliminating the arbitrary constants from the equation z equal to ax plus by plus square root of a square plus b square. This is the question. Form a PDE by eliminating the arbitrary constants from z equal to ax plus by plus root of a square plus b square. How we solve this problem? Look at this. First we have to write the given equation. Okay. Given that z equal to ax plus by plus root of a square plus b square. Okay. Let it be equation number 1. Now we have to differentiate this equation partially with respect to x and y. First with respect to x, then with respect to y. So this becomes differentiating equation 1 partially with respect to x and y. Okay, then we get, therefore equation 1 becomes, look at this, what's the partial derivative of z? Partial derivative of z is dou z by dou x. Okay, dou z by dou x. Now dou z by dou x is equal to, what is the partial differential of ax? Partial derivative of ax is, yes, x is a. And here there is no x. In these two terms there is no x. So these are considered as a constant. So the derivative of these two terms will be 0. So we get only dou z by dou x equal to a. Now what is dou z by dou x? Dou z by dou x, what is notation of dou z by dou x? Dou z by dou x is p. Therefore p is equal to a. This is equation number 2. Okay. Now differentiating equation 1 partially with respect to y also. So also equation 1 becomes derivative of z with respect to y. Dou z by dou y is equal to, what's the derivative of ax with respect to y? There is no y there. So it is considered as a constant. So derivative of ax will be 0. So derivative of by is simply b. Okay. And this term also will be 0. Okay. So dou z by dou y is equal to b. We get dou z by dou y equal to b. And what is dou z by dou y? Dou z by dou y is q. We have to remember that. The notations is very important. Okay. Dou z by dou y is q. Q is equal to B. Equation number 3. Now, by eliminating A and B are the constants. We have to eliminate A and B. So, by eliminating A and B from equations 1, 2 and 3, we get, using equations 1, 2 and 3, we get, what is this? Z equal to, equation 1 becomes Z equal to, we have to substitute the values of A and B in this equation. A is P and B is Q. So this becomes Z equal to Px plus Qy plus root of P square plus Q square, and this is the required equation. And this is the method to find out the PDE, to form the PDE of a partial differential equation by eliminating arbitrary constant. So first we have to differentiate with respect to x, then we have to differentiate with respect to y, and then we have to eliminate the constants using these three equations. Here the order of the differential equation is, what is the order of the differential equation we get? This order is first order, that is P and Q. Only P and Q is there in this equation. So the order of this differential equation is 1. Okay. Here in this question we have two arbitrary constants, and the independent variables are also 2. So number of arbitrary constants is equal to number of independent variables. So the differential, so the partial differential equation last we get is of order 1. Okay. So this is the method of finding the partial differential equation. Now another problem. 2 is equal to x square by a square plus y square by b square. Here also the given equation, we put the given equation as equation number 1. Okay. Now we have to differentiate this equation partially with respect to x and then with respect to y. So differentiating equation 1 partially with respect to x and y. Therefore we get, okay, derivative with respect to x. So derivative of 2z. What's the derivative of 2z? Derivative of 2z is 2 into dou z by dou x. Okay. This is equal to x square by a square. Derivative of x square by a square with respect to x. Derivative of x squared is 2x divided by a square. Okay. Plus y square by b square. What is this? This is a constant while differentiating with respect to x. Partial derivative with respect to x. Then this term will be a constant. So this is a derivative is 0. So we get 2 into dou z by dou x equal to 2x by a square, and we can cancel this 2. Okay. And what is dou z by dou x? Dou z by dou x is p. So p is equal to 1 by a square. Then what is a square? Which implies a squared is equal to 1 by p. Sorry, not sorry, here it is x here. So x by p. A square is equal to x by p, equation number 2. Now we have to differentiate this equation with respect to y partially. Therefore we get, look at this, derivative of 2z with respect to y is 2 into dou z by dou y. 2 into also 2 into dou z by dou y is equal to, here x square by a square, derivative of x square by a square with respect to y is 0 because there is no y here. And derivative of y square by b square is 2y divided by b square. Okay, here also we can cancel this 2 here, and dou z by dou y is q. Q is equal to y by b square, and therefore what is b square? B squared is equal to y by q, equation number 3. Now from equation 1, 2 and 3 we can write, therefore from equations 1, 2 and 3 we get 2z is equal to x square by a square. That is x square divided by a square. A square is x by p. So this becomes x by p plus y square by b square. That is y square divided by b squared is y by q. Y by q. Therefore 1x get cancelled and this p goes to the numerator. Here also 1y get cancelled and this q will go up to the numerator. Therefore, what will be the final answer, which implies 2z is equal to px plus qy, which is the required partial differential equation. Now the next question. Form a PDE of all planes which are at a constant distance k from the origin. You have to form the PDE of all planes which are at a constant distance k from the origin. So first of all, we have to write the equation of a plane. Equation of a plane is given by ax plus by plus cz plus d is equal to 0. Let it be equation number 1. Now, the distance of a plane 1 from a point x1, y1, z1. We know that distance of a plane from a point x1, y1, z1 is ax1 plus by1 plus cz1 plus d divided by root of a square plus b square plus c square. This we already studied in lower classes. Okay. ax1 plus by1 plus cz1 plus d divided by root of a square plus b square plus c square is the perpendicular distance of a plane from a point x1, y1, z1. Now, given that the distance from the origin to the plane is k. Distance from the origin to the given plane is k. So, we can write this as the distance. The distance is k. Given that distance is k. From where? From the origin. So this x1, y1, z1 becomes 0, 0, 0. Okay? Because it's the origin. So this is equal to a into 0 plus b into 0 plus c into 0 plus d divided by root of a square plus b square plus c square. Okay? Therefore we get k is equal to, this all becomes 0 and we get d divided by root of a square plus b square plus c square. And therefore what will be d? Therefore d becomes, therefore d is equal to, from this equation we can write d. What is d? D in terms of a, b, c. This root of a square plus b square plus c square comes left side. So this becomes d is equal to k into root of a square plus b square plus c square. So we get d in terms of a, b and c. So first we eliminate this d. Okay. So what will be this equation? In this equation we substitute this d here. Therefore this equation becomes, therefore we get ax plus by plus cz plus d. D becomes k into root of a square plus b square plus c square is equal to 0. So the equation becomes ax plus by plus cz plus k into root of a square plus b square plus c square equal to 0. Okay, now this equation becomes cz is equal to, take all these terms on the right hand side, so we get ax minus by minus k into root of a square plus b square plus c square, and this is equation number 2. Sorry, not equation number 2. Now we write this, from this equation we write z. So what is z? Therefore z equal to, we divide all these terms by c, so minus a by c x minus b by c y minus k into, I am taking this c inside the row, so it becomes c square. So root of a by c the whole square plus b by c the whole square plus 1. Okay, c by c the whole square. C by c the whole square is 1. So I am writing this 1 here. So this is, equation number 2. Now, in this equation, there is only two arbitrary constants are there. Which are they? A by c and b by c are the arbitrary constants. So, first, the equation of the plane contains four arbitrary constants a, b, c and d. With these four arbitrary constants, we cannot form the PDE. So, using that condition, what is that condition? The plane is at a constant distance k from the origin. That condition is given in the question. So, using that condition, we reduce this equation with equation having two arbitrary constants. So, now number of arbitrary constants and number of independent variables are same here. So, we get a PDE of order 1. Now, I am going to differentiate partially this equation with respect to x and y. Okay. Now, differentiating equation 2 partially with respect to x and y. Therefore, equation 2 becomes dou z by dou x. What is dou z by dou x? Dou z by dou x is p. I am writing only p here. P is equal to, here derivative of minus a by c x is minus a by c. Differentiation stops there because there is no terms containing x there. So, this minus a by c, and differentiating with respect to y, we get dou z by dou y is q. So, q is equal to, this is 0, and the derivative of this term is minus b by c. So, we get minus a by c equal to p and minus b by c equal to q. So, we are going to substitute these two values in this equation number 2. Therefore, again, we get z is equal to minus a by c, that is p, x minus b by c, that is plus qy. Now, minus a by c is p. So, putting minus a by c here, the minus sign vanishes because this is square. So, minus k into root of p square plus q square plus 1. So, this is the partial differential equation. Okay, students, thank you.